Let's take a look at section 8.2. We're going to be doing intersection and union. So here's something to keep in mind when we're talking about intersection. A key word, if we're talking like an application problem, is and the union, a key word here is or. All right, so something to keep in mind. I will mention this multiple times. Okay. So let's suppose we have two different sets. We've got set A. Remember, the braces indicate that we have a set. And when you have sets, the order doesn't matter in which we write them. So we could say set A was 3, 2, 1, and that would be perfectly fine. There's nothing wrong with that. The order does not matter. And in fact, if we have multiples of the same thing, still doesn't matter. It doesn't change the set. This is still the same as this one, even though there's 1, 2, 3, 4, 5, 6, and there's only 3. But because these are duplicates, we ignore the duplicates. Okay, ignore the duplicates. All right, so this one is 1, 2, 3. Set B is 2, 3, 4. And we want to find the elements that are in set A and in set B at the same time. This is called the intersection. The symbol that we use for intersection looks like this, kind of looks like an upside down U. So we would read this as A intersect B, and it's the overlap, right? So which elements are in both sets at the same time? 1 is not in both sets, 2 is in both sets, 3 is in both sets, and 4 is not in both sets. So A intersect B would be the set 2, 3. As opposed to the union, okay? The union looks like a regular U without the little tail. And the key word here is or. So the elements that belong either to A or to B or both, they can be in both, that's perfectly fine. So any of the elements in B, in A, any of the elements in B, or any of the elements that are in both A and B, that would be what's called the union. So we're going to take all of these, we're going to take all of these. We do not have to write the duplicates. Notice we've got duplicates. We only have to write the duplicates once. So the union, A union B, would be 1, 2, 3, duplicate, duplicate, 4. 1, 2, 3, 4. The set 1, 2, 3, 4. That's called the union. Okay. If you guys are familiar with Venn diagrams, the intersection is the overlap. That's this shaded region that looks like a football, kind of like a football, in the middle. Okay, so these are everything that's in A. This is everything that's in B. Where they overlap, that's called the intersection. We want to find A intersect B. That's where they overlap. A intersect B. We look to find the numbers that are in both sets at the same time. 3 is not in B. 4 is not in B. 5 is. 6 is. We already talked about 5 and 6. 7 is not in both of them. So the intersection would be the set 5, 6. Now, usually when we talk about the union and the intersection, we're using it in reference to inequalities, okay? When we have 2 or more inequalities, we call them compound inequalities. Compound inequalities are going to be separated with an and or an or. Remember, and is the intersection, or is the union. Intersection is the overlap. union, take everything. Okay, so here is how we are going to solve these compound inequalities. We're going to start with and, which is the intersection. We're going to solve each inequality individually. Because they are joined with and, the answer, the solution, will include all of the numbers that satisfy both inequalities, aka the intersection. All right, so if I have x plus 3 is less than 1 and x minus 4 is greater than negative 12, I'm going to solve this one. I'm going to solve this one. I'm going to graph this one. And I'm going to graph this one. It's easiest to figure out the intersection by looking at the graphs, multiple graphs, okay? So first thing we're going to do is we're going to solve this one over here. We're going to subtract 3. We have x is less than negative 2. And we're going to solve this one. So we're going to add 4. X is greater than negative 8. Okay, so I'm going to graph this on a number line. When you do this, it's important that you draw 3 number lines stacked. When I first started teaching this section, this unit, I told my students to draw 3 number lines, and so they did, and they would draw one over here, and they would draw one over here, and then I'm like, it's not going to help you by drawing your number lines all over the place. You have to have them stacked, and they all have to line up like this, okay? Because it's pointless to draw 3 number lines if you're just going to draw them all over the place. Okay, so we have x is less than negative 2. So here's my negative 2, and I'm going to shade in this direction, less than, so I'm going to use parentheses. X is greater than negative 8, so I've got my negative 8 down here, and greater than, so I'm going to shade in this direction, and I'm going to use parentheses, okay? Here's why it's important to draw the number lines. Here's why it's important to draw the number lines all lined up in this fashion. Because what we're looking for is the intersection. Remember, it's and, that's the intersection, the overlap. Where did I shade the top number line and the middle number line at the same time? So you guys can see roughly between here and here, right? I have shading on my first number line. I also have shading on my second number line. This, I'm only shading one of the number lines. Over here, I'm only shading one of the number lines. I'm looking for shading for both number lines. So that is going to be between negative 8 and negative 2. That's my overlap. That's my intersection. So this right here is going to be our answer, negative 8 to negative 2. We did this on the last slide. All right, so we're going to solve this one, graph the first one, graph the second one, and then our answer. It's and, which is the intersection, which means it's the overlap. So let's subtract 4x. We're dividing by negative, which means we have to reverse the symbol. So we're going to have x is greater than or equal to negative 4. So I'm going to shade it in this direction. And this one I'm going to divide by 3, which is a positive number, so I do not reverse the symbol. And so this one is my -3 right here. Okay, I'm looking for the overlap. Where did we shade both number lines? Did we shade both number lines between -4 and -3? No, we only shaded the top number line between -4 and -3. But if you look right here, I've shaded both number lines all the way down. So starting at -3 up to infinity, that's going to be my intersection, the overlap, where I shaded both number lines. -3 to infinity. Now you're like, hey, wait a minute, isn't that the same as this one? Well, it just worked out that way. Yes, it is. That doesn't mean you always are going to just take the middle one. It just happened to work out that way because they were both shading in the same direction. All right, we're going to subtract 2, and we have x is greater than 1. And where's my 1? Okay, so I'm going to shade and subtract 1. So we have x is less than -2. We're looking for the intersection, okay? And, right? Where does the shading overlap? Well, nowhere, in fact. It does not overlap anywhere. So my graph would be completely blank because there's no overlap. And my interval, empty set, there is none. There's no overlap. There's no intersection. All right, I'm going to stop the video here for now and then pick it up in another video.